Hello everyone, this is Yash Nama. Thank you for joining me on this video. This is a practice question on decision making when there is capacity constraint. Ferguson Limited makes and sells two products, alpha and beta, each of which passes through the same automated production operations. The following estimated information is available for 2020. So we've got direct material cost, variable production overheads, machine hours per product unit, selling prices per unit. Original estimates of production and sales of alpha and beta are 120,000 units and 45,000 units respectively. Maximum demand for each product is 20% above the estimated sales level. Total fixed production overhead cost is 1.47 million. This is absorbed by products alpha and beta at an average rate per machine hour based on the estimated production levels. One of the production operations has a maximum capacity of 3075 hours, which has been identified as a bottleneck which limits the overall estimated production of products alpha and beta. The bottleneck hours required per product unit of alpha and beta are 0.02 and 0.015 respectively. Requirement A, calculate the mix in units of alpha and beta products which will maximize operating profit for Ferguson Limited, taking into consideration the bottleneck hours. So whenever we have a bottleneck or a capacity constraint, the first thing we have to look at is contribution per limiting factor. So let's calculate the contribution per limiting factor. So the selling price per unit for alpha and beta are $60 and $70 respectively. Direct material cost is $2 and $40. Variable production overheads are 28 and 4. This allows us to calculate contribution. Contribution is equal to selling price minus the sum of variable costs. So we have a contribution of 30 for alpha and 26 for beta per unit. Next, so what we've got here is contribution per unit, but what we really need is contribution per limiting factor. So here the limiting factor is the production operations bottleneck hours. So bottleneck hours per unit is 0.02 and 0.015. So this allows us to calculate contribution per bottleneck hour. That is equal to $30 upon 0.02 and $26 upon 0.015. So here we can see that for each bottleneck hour, product beta offers us a contribution of $1,733, and for each bottleneck hour, product alpha offers us a contribution of $1,500. So we will rank product beta number 1, product alpha number 2 in terms of their ranking. So I'll highlight this and we will use this information at later stage. Okay, so we've now identified the ranking. Beta gives us higher contribution per bottleneck hour than alpha. So what we are required to do in requirement A is calculate the mix of alpha and beta products which will maximize operating profit for Ferguson Limited, taking into consideration the bottleneck hours. So let us determine the profit maximizing product mix. So we've got a table here where I've noted down the product, the maximum demand, bottleneck hours, hours available, and suggested units. So first we will look at product beta. The maximum demand is equal to 45,000 times 1.2 because original estimates were 120,000 units for alpha and 45,000 for beta. Maximum demand is 20% above the estimated sales level. So 45,000 times 1.2 is the maximum demand. Bottleneck hours. For 54,000 units, we need 54,000 times 0.015 bottleneck hours. So 810 bottleneck hours required. Bottleneck hours available are 3075. So we can meet the maximum demand for beta. Next, we move on to product alpha. The maximum demand is 120,000 units times 1.2. Bottleneck hours required is 144,000 times 0.02, 2,880. Hours available is 3075 minus 810 utilized for beta. 2265 is hours available. So at the most, we can produce 2265 upon 0.02, 113,250 units of product alpha. So in this way, we would have utilized all the 3075 bottleneck hours to achieve the maximum possible profit given the capacity constraint. Let's move on to part B. Part B requires us to calculate the maximum operating profit that Ferguson Limited can achieve by adopting the product mix calculated in part A. So let's calculate the maximum operating profit. So let us first calculate the total contribution that we can earn by following the suggested production. So we've suggested 54,000 units of beta times contribution per unit of beta 26 plus 113,250 units of alpha times contribution per alpha 30. So total contribution that we can generate is 4.8 million. From this, we deduct fixed costs. Fixed costs are 1.47 million. So operating profit is equal to contribution minus fixed cost 3.33 million. So this is the maximum operating profit that the company can generate by following the suggested sales mix, taking into consideration the bottleneck hours. Thank you.